All right. So one more thing we're going to do in this section, other than the unit circle, is the signs of the trigonometric functions. And so it gets a little confusing when we say signs here because we have sign like S-I-G-N and we have sign like S-I-N-E. So what we're talking about here is like the positivity or negativity of each one. Okay, so I usually refer to it as that. I say, all right, we got to talk about the positivity and negativity because I don't want to say we talk about the signs because then we're getting confused there, right? Okay, so because the functions are all determined by x, y, or both, we can know if they are positive or negative based on their quadrant, okay? Based on their quadrant. So we have the kind of abbreviated mini circle, or sorry, unit circle over here. And so if we're looking at the first quadrant, x and y are both positive, correct? So that means that sine is, so what's positive in this quadrant? Well, sine is based on y, correct? So sine is positive. Cosine is based on x, so that's positive as well. And tangent is based on y over x, so a positive divided by a negative, sorry, positive divided by a positive is, of course, still positive. And then if sine is positive, that means that cosecant is also positive because reciprocal just means flip the fraction upside down, correct? And so that means that secant is also positive and then cotan is also positive, all right? Now, when we go over to the second quadrant and all the other quadrants, that list is positives is a lot shorter, okay? So for positives in quadrant 2, well, we know that sine is based on y, and so y in the second quadrant is still positive, so that means that sine is still positive. However, the x value is now negative, so cosine is now negative. And if I do a positive divided by a negative, it's going to be negative, and so tan is also negative. So out of our 3 normal functions, in this quadrant, only one of them, sine, is positive. The other 2, cosine and tan, are always going to be negative if your angle is in the second quadrant. All right, if sine is positive, that means that cosecant is also positive. And if cosine is positive, that means that secant is, sorry, if cosine is negative, secant is also negative. And then cotan would be negative as well. So for the reciprocal functions, they're always going to be the same positivity or negativity as their kind of normal function, okay? Okay, if we go down to the third quadrant, in the third quadrant, we know x and y are both negative, right? So that would mean that sine and cosine, as well as their reciprocal functions, are going to be negative, right? So it seems like everything would be negative in the third quadrant since x and y are both negative. However, what's a negative divided by a negative? Well, that's a positive last time I checked, correct? So tan and cotan are actually going to be positive in the third quadrant because they are a negative divided by a negative, okay? So that's kind of the one redeeming thing about quadrant 3, I guess you could say, is that tan and cotan do come out positive. Okay, and then lastly, quadrant 4 here. So the y value is still negative, so sine and cosecant would be negative. However, the x value is now positive, so that makes cosine and secant positive. And then a negative divided by a positive is a negative, so that would mean tan and cotan are negative. Okay. So that is kind of the list over here, the extended list of every trig function and whether it's positive or negative in each quadrant, okay? And that's going to be very important for us today. Now, there's a lot easier way to remember this, and that's kind of written over here. And so they say ASTC. A popular way that people remember this is they say all students take calculus. Now, I know that that's not exactly true, but I don't know. I hope it's true. Even if you don't take calculus here at Tustin High, you can take it in college, right? So all students take calculus. Reminds you the ASTC. And what that tells you is which of the normal 3 trig functions is positive, okay? So in the first quadrant, everything's positive. And by normal, I just mean sine, cosine, and tangent. So in the second quadrant, sine is positive, which means everything else is negative. The third quadrant, tan is positive, which means all of the other 2 are negative. And then in the fourth quadrant, cosine is positive, which means the other 2 are negative, okay? And then for the reciprocal functions, you just got to remember they match up with their sine, cosine, and tangent. So this little trick is just for sine, cosine, and tangent. It does not include cosecant, secant, and cosecant. They always go along, though, with their reciprocal function, okay? Okay, so now we're going to use this to determine in which quadrant an angle lies. And so they give us always 2 clues on this one, okay? So we get 2 clues. We need 2 clues in order to find it. So what I always say for these ones is draw your XY plane, okay? And then interpret the clues. So they say, so I'm just going to do the first clue first. Sine is less than 0. That means sine is negative, correct? Okay, so the first clue says sine is negative. So with the first clue, you should be able to cross off 2 quadrants. So if sine is negative, they told me, I should cross off the 2 quadrants in which sine is positive. Well, sine is definitely positive in the sine quadrant, correct? So that's not it. I'm going to cross that quadrant off, the second quadrant. But sine is also positive in the all quadrant, right? Because everything's positive in the all quadrant. So based on that first clue that sine is less than 0, it could be the third quadrant or it could be the fourth quadrant. I'm not sure yet. So now I'm going to go to the second clue. And the second clue is going to allow me to eliminate 1 more quadrant. And then whatever is left is my answer. So this one says cosine is less than 0. So that means cosine is negative. So if cosine is negative, it cannot be the fourth quadrant because that's the cosine quadrant. And therefore, this one's going to be in quadrant 3. There we go. All right, let's try it again. All right, some more negatives here. So tan is negative. Sine is also negative. Actually, I'll hold off on that. So based on tan being negative, it cannot be the third quadrant because that's the tan positive quadrant. It cannot be the all quadrant. So first clue allows me to eliminate 2 of them. Second clue, sine is less than 0. Well, that means sine is negative. It cannot be the sine quadrant. So this one must be quadrant 4. So first clue eliminates 2 quadrants. Next clue eliminates another 1. Only 1 left. That's your answer. Okay, now we get into reciprocal functions here. So this one says secant is greater than 0. So I mean, secant is positive. I kind of always write that as, I change that to say cosine is positive. So whenever they give me a reciprocal function, I just rewrite it as the regular function. But remember, that doesn't change whether it's positive or negative, right? So if secant's positive, cosine is also positive, okay? If we knew what the number was, we would flip the fraction. But if we're just doing positive and negative, it stays the same. Okay, cosine, positive, okay? So if cosine is positive, I would say it cannot be quadrant 2 or quadrant 3, right? In those 2 quadrants, cosine is negative. We know that because cosine is the x value. So if cosine is positive, it must be on the right side of the graph, correct? Okay. So then this one says tan is negative. So if tan is negative, I would cross off the first quadrant because in the first quadrant, everything's positive. So if tan is negative, it cannot be the first quadrant. If cosine is positive, it can't be the second or third. And therefore, this is going to be another quadrant 4. All right, and one more here. So cosecant is greater than 0. That to me says sine is positive. So if I was to draw this, sine is positive. Well, we know sine is y, so it has to be above the x-axis. Or you could look back at the chart here and be like, okay, sine is positive in the top two. You do that as well. Cosine is negative. Well, that means it cannot be the first quadrant since everything is positive in the first quadrant. So this is going to be in quadrant 2. There we go. All right. Let's, oops. We're going to scroll down. I'm going to stop for 15 seconds here in case you missed any of that. And then we're going to scroll down to like the last set of problems on, it's probably page 4 or 5. Here we go. All right, so these last 4 problems here we're going to do on page 4. Find all trig functions from the value of 1. So our goal here is to find all 6 trig functions. We actually kind of did this before where we drew a triangle, right? And then a triangle with the sine of 4/5. And then what's all the other 6 trig functions, okay? So we're still doing that, but now we're doing it in a quadrant. So let's draw our XY plane here. Now in this case, they tell me what quadrant it's in. And so I'm going to go ahead and draw my triangle in the 4th quadrant. Now, the key to this is you always shoot out from the origin and then always connect to the x-axis. When I used to teach this class with Mr. Miguel, he always said, if you drew all 4 of the triangles in all 4 quadrants together, it would look like a bow tie. So you can see right here, all of those going out. Starting at the origin, shooting out into the quadrant, and then always connecting to the x-axis. Okay, now, they said the sine is -4/5. So I know one of these sides is going to be 4, and one of these sides is going to be 5. Or sorry, the opposite, sorry, this is our angle. It's not just any side you want. But opposite is 4. Hypotenuse is 5, right? That's sine. Opposite over hypotenuse, 4/5. However, one of those needs to be negative. Which one's going to be negative? The 4. Why is the 4 negative? Because it's going down, right? Isn't down a negative direction? Yes, it is. But on these ones, and you probably want to make a note of this, the hypotenuse is going to always be positive. It's because it goes diagonally, so it's not really an up or down. It's diagonal. So just trust me on that one. The hypotenuse is always positive. Okay. All right. So we need to use Pythagorean theorem to find the last side here. So we're gonna say x squared plus -4 squared equals 5 squared. So x squared plus 16 equals 25. Subtract the 16 over, x squared equals 9. And we square root it, and x equals plus or minus 3. Since we created the square root, we really do need the plus or minus here. Now, usually in geometry, you say like ignore the negative answer. But in this case, we actually have to consider it because although there's no such thing as negative distance, when we're on the coordinate plane, it is possible that it's a negative direction for x, okay? Now this 3 is right here. So from the origin, that's going to the right. So I'm gonna say that's positive, okay? So here's the directions. Right is positive, up is positive, down is negative, left is negative. You guys already know that, right? Just we're talking about x. If we're talking about x, right is positive, left is negative. If we're talking about y, up is positive, down is negative, okay? All right, so now we're gonna state all the trig functions. So now we can say sine, well, we actually already knew sine is -4/5, right? Then we could say cosecant is -5/4 if we flip that upside down. Cosine is 3/5, which means secant is 5/3. Tan is -4/3. And cotan is -3/4. So the other thing we notice is that when we're in quadrant 4, what's positive and what's negative over here matches up with how we drew our chart back up on page 3, right? Cosine in quadrant 4, if I go back up here, cosine and secant should be positive, sine, cosecant, tan, cotan should be negative, and they are. All right, let's skip number 2. Let's just, I think I'm gonna need more space for number 3 anyway. So I'm gonna use this space for number 3. Oh, wait. Oh, no, that's good, that's fine. Okay, so number 3, okay. So number 3 now, instead of telling me what quadrant it's in, I need to choose what quadrant it's in, okay? So let's find out what quadrant it's in, and how we're gonna do that is how we did it on the last page. So they're first telling me that tangent is positive, correct? They don't tell me it's greater than 0 now, but they literally tell me the number and it's a positive number. So if tangent is positive, I know it cannot be quadrant 2 nor 4. Now cosecant is negative is really telling me sine is negative. So if sine is negative, it cannot be quadrant 1 because everything's positive in quadrant 1. So it must be quadrant 3. Okay, now I'm going to start filling out sides. So my tangent is 5, but remember that that's really 5/1, correct? 5/1. So from my angle, which is always in here in the middle, okay? Oh, that's another thing I should have mentioned. Your angle on these is always the angle closest to the origin. So from that angle, my opposite side should be 5, so that's the opposite side. My adjacent side should be 1. However, those are actually not 5 and 1 because look at the direction that they're going. This one's going down, so it's -5. This one's going left, so it's actually -1. Now, does that still give me a tangent of positive 5/1? Yes, it does. Okay, but since I'm in the third quadrant, those x and y values have to be negative, and that's really what those represent, okay? All right, so now I'm going to do Pythagorean to get my last side. This time I'm looking for the hypotenuse. So I have -1 squared plus -5 squared equals c squared. So 26 equals c squared. Square root it. All right, we never want a decimal for this. So if it's a radical, we're going to do simplest radical form. So does radical 26 break down? Well, that is, what is that? 2 and 13. So I would say no. So technically this is plus or minus rad 26. So is this positive or negative? I'm going to say it's a positive rad 26. Remember, the hypotenuse is always positive. And so now I can go ahead and identify my 6 trig functions. So sine is going to be opposite over hypotenuse, -5 over radical 26, which means cosecant is negative radical 26 over 5. Cosine would be -1 over radical 26. And secant would be negative radical 26 over 1, which I would just write as negative radical 26. Tan we already knew was a positive 5, but my triangle does confirm that. Opposite over adjacent is -5 over -1, which is positive 5, which means cotangent is a positive 1/5. So there we go. We see that tan and cotan are positive in the third quadrant. The other four are negative in the third quadrant, which is how it should be. All right, last one here for today. Secant of theta equals -2. Okay, so I would actually interpret this one as saying cosine of theta equals -1/2. Okay. So they're saying cosine of theta equals -1/2. So they're saying cosine is negative, correct? So cosine negative means I cross off this quadrant and this quadrant. Now they say sine is also negative, which means I would cross off the second quadrant. So my triangle would be in the third quadrant, with my angle being right next to the origin. Okay, so I know the cosine is -1/2, so I have my adjacent is -1, my hypotenuse is 2. Going to use Pythagorean for the last side. So that's going to be -1 squared plus, I'm going to call this y squared this time, since it's really a y value, equals 2 squared. I kind of already know that y is going to be negative here since I'm in the third quadrant. So I'm already thinking about that. So 1 plus y squared equals 4. Y squared equals 3. Y equals plus or minus rad 3. Like I said, since it's going down and we're in the third quadrant, that's going to be a negative rad 3. We have our three sides now. We can just run through our trig functions. So let's do it. Sine would be negative radical 3/2. Cosecant is -2 over radical 3. Cosine is -1/2. I kind of already knew that, but I'll just rewrite it here together. Secant, I definitely knew was -2. Tangent is going to be negative rad 3 over -1, which is positive rad 3. And cotangent, 1 over radical 3. Beautiful.